Hi, welcome back. I'm Dr. Benedict Gaster from the University of West of England, and this is the third part in a series of short videos about version control. And in particular, this video we're going to look at the source control system called Git. This is the symbol for Git. You'll see it lots of places. Its idea, I believe, is that you're coming down on this master tree and you can branch off. We'll talk all about what that means in a minute. And it's very widely used now and has become popularized partly by its developer, who's called Linus Torvalds. I'll let this sentence talk for itself, but you'll probably know him from it as the author and original developer of Linux, the operating system that is widely used in many institutions. And more recently, he wrote Git. And my understanding is the reason he developed it was he felt other source control systems didn't meet the needs of his requirements, of what he thought a source control system is. And being Linus Torvalds, he said he'd write his own, and it's become hugely successful. And so you can tell he's written two of the most successful pieces of software on the planet today. Okay, well, like most pieces of software today, Git can be downloaded from the internet. It's completely open source and free, and if you've got OS X or Linux, then you'll probably find that it's already installed. If not, the links are included here in the slides for you to do that. By default, it doesn't come installed on Windows, but again, the link is included here in the slides, and it's easily obtainable free of charge. So what do you do when you do this? So Git is by default is a command line tools, which means that on Windows you'll need to open CMD, or the new Bash for Windows tools. And on Linux and OS X, you can use some of the terminals provided. I use the Bash shell, but a C shell is another example to do that. But you'll need to open up a command line and create a new directory. You can put it just at the root directory if you want, or put it where you're going to do your project developments normally. I often have a directory called dev, for example, where I create initial projects that I'm working on before they find a more permanent home. So once you're in there, create a new directory and open it, i.e. change into it, and then you can run your first Git command, which is Git. All Git commands start with the word Git, that's the actual command, space, init, and this will initialize and create a new repository. A repository is where you store all the files that you want to be maintained under version control. If you have an existing repository, then you can clone it or make a copy of it. And we can do that by running the command git clone path to the repository if it's a local path. Or if you have a remote server, which we'll talk more about in the next video, and you can do that by using passing the path to the actual host and then the path to where that repository is stored. So a common one that people use, for example, is GitLab, which is a public Git hosting repositories, or a GitHub is another. And if you work in an institution like I do at the University of West of England, we have our own local repository. Our one's based on GitLab, but there could be other ones too. Okay, again, you're cloning that repository, so you do git clone and then the path to the repository, whether it's local or remote. This will copy all the existing files in that repository down into your local machine. Now the really nice thing about this is if you closed your laptop or closed and walked away for the day and you no longer had internet access, maybe you're on a plane or maybe you just didn't fancy connecting to the internet, then all those files are a local copy on your machine and you no longer need to be connected. You can work remotely, carry on working, edit files, and then when you connect back online, you can communicate and sync with the remote repository to update or push updates of your changes, or download updates if someone else has made changes that you want to pick up. So that's a really nice feature of Git. So the workflow in general is going to look like this. I.e., your Git workflow is that the local repository, the directory where you're working, which is called the working directory, consists of 3 trees. These are all maintained by Git. The first one is your working directory, which holds the actual files, and these are just the files that you'll edit and convert. I use Atom, for example, or text editor to edit those. You might use Emacs or VI, Visual Studio, whatever it is you use to edit your source files. You can do all those just as normal without any kind of interaction with the Git world. The second one, which is maintained in a directory, it's actually remained in there's a directory which is prefixed with a dot on Linux and OS X for a hidden directory. And inside that is an index, which acts as a staging area. So this is the area where you're going to commit or add your initial changes to. They're just going to be sitting there waiting to be pushed out into the remote repository, for example. And the third one, and finally, is the head, which points to the last commit you've made. So once you've added it, you haven't yet committed it. But once you've committed it, it'll be added to the commit, and that's where the history and the tracking begins. To add and commit, you can propose changes. For example, add it to the index using git add file name. You can use, star if you want to add multiple files, or star.png to add multiple PNG files, or you can be very precise and just add the particular file name. This is the first step in the basic Git workflow. You edit some changes to a file, maybe you create a new file, or you edit an existing file, and then you do git add file name to add those. At this point, they're just committed to the index. They're just added to the index. They're not yet actually committed. To commit them to the head, you need to run the command git commit, and then you need to, when you do that, if you run it without any additional arguments, then it will pop up and ask you to add a commit message, i.e. a comment about what the change is. And this is the thing that the version control system will manage to provide a history about the information of those changes. You can use -m with a speech mark text message inside it, and this can be used as your commit comment as well, if you don't want to let it pop up in editor. Once you've done all this, you've added your changes so that they're tracked locally in the index, and then you've committed them. They are now in the head. Okay, that means that locally you've now got a copy and a history of all the changes you've made to that particular file, or the many files if you added those, because the commit will do all things that have been previously added since the last commit. But the important point of this is that you haven't made those changes visible to the remote repository yet. In this case, when we want to make them visible remotely, we call a thing called pushing. Your changes are now in head of your local working copy. To send those changes to your remote repository, you can execute the command git push. In this case, we're going to pass in the origin and master. And master is our branch. This is the default branch that Git uses in all cases, and it's the way most of the final releases will be derived from, for example. You can change master to whatever branch you want, and we'll see how to create branches in a moment. You can name your own branches for implementing feature X or feature Y, for example, and then you can push things, merge things to that branch, and then later on you can merge things back into master once you've finalized and got those things committed. Okay, if you have not cloned an existing repository and want to connect your repository to a remote server, so i.e. you did a Git init locally on your machine and you have not yet associated that with a remote repository, either by cloning it or by connecting it in another way, then you can do that. But you're going to have to do that before you can do the push. So in this case, you do git remote add origin server, and the server is the remote host that you want to load it up to. Once you've done this, this just associates this particular repository with the particular host in mind. Then you're able to push your changes to the selected remote server. So this is a very common workflow, that you'll create a repository locally, add some things to it, populate it, including a README file, for example, and maybe some basic source files that you've done, and then you'll associate a remote repository with it and push your changes up to it. So branching is one of the key features that Git offers, and it allows you to develop new features and capabilities in isolation from each other. Okay, the master branch is the default branch when you create a repository, and this is often used to keep track of all completed work. But whilst we're kind of developing things, adding a new feature, say feature X, for example, we might create a branch, which in this case, in this diagram, we name feature X. And then we do the development on it, commit things to that, check them in. We can even push that up to the remote repository if we so choose. But once we've done that and we're happy with it, we've added our tests and we've done that, we'll merge all those changes back in to the master. Okay, so the master branch, and then people can pick those up from the master. They can come along and pick your branch up if they choose to, but generally people will work on their branches and the master. Maybe if you're co-developing a new feature, as I might with my colleague Craig, then we might work on feature X branch together, and then one of us will merge it into the master at some later date. Okay, so how does branching work? Well, it's fairly straightforward. To create a new branch named feature X and switch to it, we can use the command git checkout -b feature _X. Okay, now this is now checked out that branch. There may not be any additional changes initially because we haven't done anything to it. And so, but now any future commits will happen against that branch. Okay, we can switch back to master or to any other branch at any time by using git checkout and then just typing in the name of the branch. At some point, depending on how your organization or how you like to work, you might want to delete the branch because you've completed that work and it's gone back onto master. And so there you can do git branch again and -d, which for delete, and then feature _X, which is the name of the branch. And it's important to note that a branch is not available to others unless you push that branch to your remote repository. So here you can see we're using the command git push origin and the branch name. Originally we used git push origin master because we were pushing to the master branch, but now we're pushing to our own branch, say feature _X, and so we change the origin and set the branch name to that. Okay, well, it's quite likely that if you're working on a project with lots of other developers, that at some point you're going to want to pick up changes from other people and not just your own ones. And so to do that, we can update, and we might potentially need to merge. And what do I mean by merge? Well, say that you're editing a file and a colleague of yours is also editing a file. Maybe she has made a change to line 10 and you've made a change to line 100, and you want to get both of those changes into the file. So then you might merge her change into your change to file with your change, and then you'd have a new file which has both your changes. So that's what we mean by merging. So we can pick up changes from someone else or from the remote repository by doing git pull, and this will pick up the newest commits. Again, we haven't mentioned a branch there, but we could use a branch if we wanted to, and this will fetch them all into your working directory, your working repository that you're working on in the machine, and the directory that you're in is the particular Git repository that you're working on. You can merge from another branch into your active branch if you choose to. For example, you could merge from master into feature X or from feature X into master by doing git merge branch. In both cases here, Git tries to auto-merge. So I said that our colleague, she had changed line 10 and I changed line 100. Well, in that case, it's fairly easy to do the merge. But what happens if she'd also deleted line 100 or line 99, which would be around the place that we were changing? So in this case, it may not be possible to do an automatic resolution of conflicts, as these things are called. And so in this case, you are responsible for handling these conflicts and manually editing the files to make the merge work correctly. And Git will actually give you information. It will show you where these conflicts arise, and so it can make editing them fairly straightforward. Okay, well, that concludes our brief introduction to Git. But up next, we're going to do a little bit of Git in action. I'm going to get onto the command line on my Macintosh here, and I'm going to show you how to create a repository, merge it in from a remote repository, and add a simple README file with a change in it. Nothing more than the commands we've already done, but then you'll actually see them in action, actually see me typing them in, which may be helpful. Okay, thank you for listening.